Okay, good afternoon, everybody. Okay, today will be the second part of the circuit, the electric circuit topic. Okay, this particular part focus on one of the arrangement that we have, the parallel arrangement. Okay, same as the previous video where we talk about series. In this particular video about parallel arrangement, we will investigate what happened to the potential difference, what happened to the current, and what happened to the resistance of the cable of the circuit when they are arranged in parallel arrangements. Now, so without further delay, we'll go straight into the video. Okay, here we go. Right, and now the first section here. Okay, parallel circuit. How do we know the arrangement is how do you know the circuit is in parallel arrangement? One of the common thing that I always tell students is you look at the path, look at the wires. Okay, which means if the arrangement or the path of the wire allows some splitting, okay, I will know that these particular components are arranged in parallel because splitting is one of the characteristic of a parallel arrangements. Okay, so the moment I see the particular section is the wire split up, I will know that that particular arrangement is parallel arrangement, and I'll take note of the behavior or even the mathematics involving parallel arrangement. Just to recap, if it's the cable is one straight cable, one single path, that particular arrangement will be what we know as a series arrangement. So try not to mix up the two. So now for parallel arrangement, what actually happens? Okay, the components, okay, there are more than uh two loops or two paths. Okay, so when you have two or more loops, okay, or sometimes we call two or more paths, okay, and one because the path splits up, so there are alternative paths for the circuit to the current to flow. So as a result, okay, you'll find that the current in one branch, okay, second branch, okay, they may or may not be different values. Okay, they may be different, they may be the same. Okay, but I do know one thing is that the wires, the current in the two branch, I1, I2, they will make up, or if I sum all the current in the branch together, I1, I2 together, they will actually combine and they will become the current at the main branch here, which is I1. So what we are looking at is this is what we know as a splitting of current, whereby from one big main branch, I will split to multiple paths. So if I have three branches, okay, if I have three branches, my current will split up three times. So which means if I have three branches like this case, okay, so I will know that the arrangements, the current arrangement, I will know in terms of mathematical, the arrangements of my current, it will be that the current flowing through this branch, if I add up this branch and I add up these three branches, okay, this current flow in these three branches, the answer will definitely be this answer here, the current flow in this particular main branch. Okay, so sometimes you'll find that we actually rewrite into this. Okay, I give me, okay, let me hide the thing, let me erase the thing. Okay, so like I mentioned before, if you have three branches, okay, you'll find that the current in the main branch, in the first branch, second branch, and third branch. Okay, so you have what we call, you add up to become I1 plus I2 plus I3. Okay, you add up to become the current in the main branch, which is I total. Let's say I give a name I total. Okay, so this is what we mean by the current actually splitting up. Okay, so the three path I will add up, it will become the main branch. Okay, so this is what we mean by current splitting up in the parallel circuit. Now, what about the potential difference? Potential difference actually is quite I will not say tricky, but it's slightly different in the sense that the potential difference across each of the branch, if I know that R1 is parallel to R2, okay, in a sense that the current come and is split up and split up down. So I'll know that the potential difference across this branch, okay, it will be the same as the potential difference across the second branch, because when we talk about potential difference, okay, we are talking about 2 points. Okay, so for R2, the 2 points they are looking for is this 2 point, first point and this point. So the difference between these 2 points, let's say I call this X and I call this Y. So for R2, for potential difference for R2, it will be the potential difference across the 2 point X and Y. And similarly, if you look at the potential difference of R1, okay, or V1, okay, R1 here, it will also be the potential difference across the 2 point here, which is also coincidentally happen to be Vx, So you find that the two potential difference across the two component, they happen to be the same 2 points. And as a result, that's why we can say that the potential difference across the two branches, VR2 and VR1, the potential difference are actually the same. That's why in terms of parallel arrangements, in terms of branches, parallel branches, we always say that the branches always have the same potential difference. And sometimes coincidentally, the branches is actually connected in parallel with the battery itself, which is the EMF. So sometimes we have a coincident mathematics whereby we say that V1 is equal to V2 and it also equal to V3. Equal to the EMF, the potential difference of the battery itself. Okay, so that's why in terms of potential difference, the potential difference across the branches are the same because the potential difference are across the same 2 points. Okay, despite them being the same two separate branches, but the 2 points between them, they are always the same. Now, same thing. So how do you look at it? Okay, we use the basic formula. So now the formulas that we have from the previous topic, one of the formulas that we need to draw back on is R equal to V over I. Okay, this formula, or sometimes we actually rearrange it to become V equal to IR. Okay, which is what we call Ohm's law. Okay, now in this formula, same thing, we look at the arrangement first. Okay, so before we look at the math, we look at the arrangement of this circuit first. Okay, so you look carefully, you find that the path here, okay, I3, your current follow this path. After that, it actually split up into two paths. So I know because of the splitting, I will know that 10 ohms and 20 ohms, they are in parallel arrangements. Okay, so I will need to take note of of maybe the properties. So example, if I know they are parallel, I will know that because of parallel arrangement, the properties, I will know that I3 eventually will split up to I1 and I2. And because they are parallel arrangement, I1, I2, the sum of I1 and I2 will actually be equal to I3. So this is the property that I mentioned in the previous slide. Okay, so now once I have it, same thing, I will look at the individual current. So to find I3, I actually need to find I1 and I2 first. So how do I find I1? Okay, simple. Resistance equal to V over I, this formula from the previous topic. Let's use it here. Okay. I know the arrangement for the branches. Okay, look at the potential difference across 10 ohms. Okay, is actually 6 volts. Okay, so the potential difference here will be 6 volt. Okay, because the potential difference across the 10 ohm is actually the same as the potential difference across the battery, okay, the EMF. So I will know that the I1 potential difference here is actually 6 volts. Okay, so that's why I will know I1 is actually 10 amp. And similarly for I2, I use back the same formula, V over I. Voltage of 20 ohms, okay, potential difference of 20 ohms, same thing, is across the 2 point. It happens to be the same point as the EMF, which means V2 will also happen to be 6 volts. Okay, so which means the answer here will be 0.3. And if I have I21 and I2, I will know that the sum of these two current will be actually I3. And I will know that it will be 0.6 plus 0.3, and I will know the answer is 0.9 amp. Okay, this is how I use the property of parallel arrangement or sometimes series arrangement, all these properties to actually aid in my solving of the questions. Okay, this is where the mathematics and the physics, the concept, they will meet and they will help you to solve the questions. Okay. Now, the third component that we look at is the resistance. Okay, resistance. Okay, same thing. I will not bore you with the math. Okay, so same thing is I want to combine them into a single resistance. The reason is the same as series. I want to see whether I can actually pair up or I can merge all the resistance together from 10 resistance in parallel, 2 resistance in parallel. Can I merge them into a single resistance? Partly also I want to save costs, and also partly also because I want to string the circuitry from maybe from R1, R2, the circuitry so big, okay, I want to string it to just a small one, Okay, so this is one of the few main reasons that we are looking for when we look for effective resistance, when I want to sum up all the resistance. Okay, because I want to get a effective resistance that will actually behave like many small resistance. Same thing, the components. Okay, the formulas for resistance will be the effective resistance, the total resistance here. Okay, it will be a combination of the reciprocal. So for example, the effective resistance, okay, so let's say I have 10 ohms and 20 ohms. So how do I find the effective resistance? I will have the reciprocate of R1 and R2 plus 1 over R2. R1 plus 1 over R2, which is 1 over R total, 1 over R10. R1 is 10 ohm plus 1 over 20. So once you have, if you use your calculator, you will find that the result here will be 3 over 20. Okay, remember this is 1 over RT. It's not effective resistance yet. So once you have it, okay, remember to inverse the thing, which means RT will be 20 over 3. Flip it upside down, and you'll find that the answer here will be 6.67. Okay, 6.7 ohms. Okay, so remember, if you look at the resistance formula, effective resistance formula for parallel arrangement, it will be always 1 over R1, 1 over R1 plus 1 over R2 plus 1 over R3, whatever branch you have, the reciprocal, add it up. Thereafter, remember to flip them again. Okay, because the final answer the answer the intermediate working they are looking out for is 1 over RT, but you are looking at RT. Okay, not 1 over RT. So remember to flip the answer up again at the last stage of your working. Okay. Now, okay, this is what I mentioned. Okay, so if you have multiple branches, a lot of branches, okay, one R1, R2, R3, R4. So what you do, don't worry, just reciprocate everything, just add it up together. And remember, this equation give you 1 over R. So after that, please remember to flip R again. Okay, to flip the answer, the combined fraction, flip it again. But eventually, ultimately, you want this form. You want R effective. Okay. And same thing, the effective resistance is smaller than the smallest one. This is, I think, quite easily explained because the math, okay, because of taking fraction. Okay, in summary, okay, if you look at parallel circuit, same thing. We look at the current, how current change. We look at the voltage, and we look at the resistance. How these three party actually change when we have parallel circuits. Okay, so for parallel circuits, the current, like I mentioned, is the sum of individual currents in each branch. So if I have 10 branch, I'll add all the branches. It will give me the final number will be actually the main current, which is what we call the main branch. Okay, and also I will know the potential difference across the branch. Here, take note, is across the branch. Whether like I mentioned in the previous slides, okay, you will find that I mentioned V1 equal to V2 equal to VEMF. Okay, take note, it depends on whether V1, V2 equal to EMF. It depends on your arrangement. Sometimes it will not want. Why? Because sometimes your branches V1 and V2, they might not be a pure parallel branch. It might be the circuit might consist of partial a bit, maybe a bit of the circuit is in series arrangement with another portion. This parallel arrangement is actually in series with another parallel arrangement, so it will be a mixture circuit. So one thing for sure is that I will not know whether the branches is it equal to EMF. I will not know. But one thing for sure is that I know for each branch, okay, the potential difference is always the same because they are always having the same 2 point VXY. They are always the same one. So I will do know that the branches are always the same. Okay, and the last one, I will know that the resistance, okay, it will be a reciprocate of the sum of the individual resistance. Okay, same thing here. I want to highlight again. Okay, please remember to flip the final answer because the final answer you want is you want RT. Okay, so remember to use a calculator, add up all the fraction, and after that, flip it up again. Okay, so in a nutshell, okay, we have covered two type of arrangements. We have covered series and we have covered parallel arrangement. The two arrangements, they have the same breakdown, which means in this arrangement, we look at how the current change, we look at how the potential difference changes, and we look at how the resistance, the effective resistance changes due to the arrangements. Okay, then after that, I use the my math to solve. In the previous example, we look at in the two particular section here, is we look at them as a pure series and pure parallel arrangements. But sad to say is that in terms of in real life, most of the arrangement of a circuit in of circuit arrangement is actually a mixture. So I can have a circuit that consists of series and parallel. So in the next section here, we'll look at what happens if I get a mixture circuit. When I get a circuit with partial series and partial parallel, what should I do? Should I do the series first? Should I do the parallel first, etc., etc.? Okay, because in most of the time, we will not get a pure series arrangement. We will not get a pure parallel arrangement. In fact, we get multiple mixed circuit. A bit one side series, one side parallel. Then maybe I will get some one has sum up, they will become another CE, will become series with another circuit. So it'll be like a mixture thing. Okay, so the next segment here, we look at more of the applications. Okay, anything, any comments? Okay, any questions you have, any feedback, any improvement that I need to make, you let me know in the comment section. Okay, if not, okay, just remember to subscribe to my channel to get the latest update for the subsequent topic and subsequent videos. Okay, if not, thank you. Okay, and remember, okay, refer back to your notes or your textbooks. Okay, read through again. Okay, because after one video, I don't think everybody will be a superb at the circuit. Okay, so please refer back to your notes or even your teachers. Okay, for clarities or for more clarities. Okay, thank you very much. So see you.